Hello everyone. Welcome to the part 2 of the two-part video series for Arastu Systems Ethernet 1G 10G digital switch solution. Thank you for stopping by. In the part 1 of the video series, we have given a brief description of our Ethernet solution and also demonstrated simulation behavior for a 4-port switch. Before we dive deep into the technical aspect of the switch, let me give you a brief description about Arastu Systems. So basically, Arastu Systems is a product engineering company which have been contributing in the electronic industry through silicon and software engineering. There are 3 key areas where we cater to. One is semiconductor IPs and solution, where we provide complete front-end, ASIC front-end digital switch solution and IPs specifically in the DDR and Ethernet area. Secondly, hardware and board development capabilities. We have a team which works hand in hand with our customer and help them with the board development aspect. Third is the software and IoT. In this part, we will be demonstrating the FPGA validation for the switch solution on a 4-port Xilinx FPGA platform at 1G speed. For the purpose of validation, we need a programming file, commonly known as bit file, in order to load it inside the FPGA. For the purpose, we have already synthesized a project of a 4-port switch at 1G speed using Xilinx Vivado 2018.1. Let's check the settings first. As we can see in the general settings window, we have selected Vertex 7 VC709 FPGA board as a targeted project device. As synthesis is already completed, click on the generate bit stream from the flow navigator to generate the bit stream file. As we can see, bit file generation is completed. Let's program the FPGA by using this bit file. Open the hardware manager from the flow navigator and program the device by using the currently generated bit file. Our device is programmed now and ready for validation. So we're using Xilinx Vertex 7 VC709 FPGA board, which are having 4 ports. We can see that all 4 ports are not connected to any machines. In that case, let's check the link up status by checking the LEDs here. We can see that LED L4 indicates whether the link of port 0 is up or not. Similarly, LED L5, 6 and 7 indicates the link up status for port 1, 2 and 3 respectively. Now let's connect machine 0 to port 0 using the LAN keyboard. We can see that LED L4 is glowing now. That means the connection between port 0 and machine 0 has been established. Now let's connect machine 1 with port 1. Now we can see that L5 is glowing now. LED L5 is glowing. Similarly, we will connect machine 2 and machine 3 with their respective ports. In the same manner, LED L6 and L7 are glowing now. That means the connection between all 3 ports and their respective machines have been established. Our switch solution is providing very low latency, such that it can generate high throughput when an application demands. Let's look at it by looking at an example. From machine 0 with the IP address 169.254.148.198, we are sending one ping request to machine 1 having the IP address 169.254.105.129, and machine 1 is giving a response based on that request. We can see from the command prompt that reply from machine 1 is coming. We can also notice that all packets are received with latency of less than 1 millisecond and maximum round trip time is less than 1 millisecond. To calculate the switch latency, we have captured the waveform by using Vivado's integrated logic analyzer. In the captured waveform, receive and transmit side AXI interfaces are shown. We can see from the captured waveform that On the receive AXI side interface of port 0, ping request is coming from machine 0. By looking at the layer 2 header, we can see that destination address is EC F4BB5F E135, which is the MAC address for machine 0. And the source address is 3C970E67AD4C, which is the MAC address for machine 1. Switch has received this frame on port 0 and forwarded it based on the destination address to port 1, as the machine 1 is having the MAC address 3C970E67AD4C is connected on port 1. On the unit of time, we can see that the latency of the switch is 20 clocks in this case. Now let's put a heavy file transfer from machine 1 to machine 0. Open the shared folder located at machine 1 by accessing it on the locally connected network. Now copy this file into local destination at machine 0. We can observe that the speed of the transfer is around 100 Mbps, which is equivalent to speed of 1G. Apart from low latency, our switch is highly configurable as it supports up to 24 ports. It also supports multiple speeds such as 10M, 100M, 1G and 10G. To learn more about Arastu's Ethernet switch solution, you can watch the first part of this video series, where we have talked about the features and simulation behavior of the switch. In order to know about Arastu Systems, please visit our website www.arastusystems.com, or else you can also email us at marcom@arastusystems.com. Thank you for watching. See you folks until next time.